Welcome to this session about the Pimcore Data Director bundle. First, some words about me. I'm Jan Walter, working at Blackbit as a lead developer. I'm a Pimcore core contributor since 2018. Perhaps some of you know me from the Blackbit Neue Medien GitHub handle. And for my work on Pimcore as an open source project, I received several awards. I'm a specialist for import, export, and automation with Pimcore. And in this context, we often use the Data Director bundle. So what is this? It's a bundle for efficient connection of external systems to Pimcore. So you can implement imports and exports with this bundle and also automate the data control within Pimcore. The bundle is in development since 2013 and it evolved with real user requirements to a really battle-proven solution. For example, it's in use to import 8 million products and update 300,000 products daily on a single Pimcore system. Other applications are connecting ERP system, web shops, InDesign or other external systems to Pimcore. It's used by over 100 clients, some of them are listed here, and a lot of more clients through our collaborations with other agencies and Pimcore partners. So let's look in detail how the Data Director works. Here I have a little diagram how imports work. So at the top we have the import formats, and when we want to do an import, we extract the data from our import documents and as a second step, map those data fields to our target class fields. When we set up an export, then it's the other way around. We begin at the bottom. First, we extract the raw data from the Pimcore elements and then map the raw data fields to our target export document fields. And when we want to do automation within Pimcore, then we extract data from the Pimcore elements and map the fields to the same Pimcore elements or to other. So in general, this all works the same. The Data Director provides a unified interface for all of those operations. But let's see how it works. I've prepared a Pimcore demo system here with two classes, a manufacturer and product. And I've uploaded a CSV file here as an asset. You can see it here. It has 4 columns, SKU, product name, manufacturer, and categories, and 2 products. And I'd like to import the manufacturers as separate objects, and afterwards the products, and assign the manufacturers to the products in a many-to-one relation. So let's do that. First we go to the Data Director and create a new dataport named import manufacturers. And then on the right side, we have the import configuration. So our import source type is CSV in this case, and we want to import the data to the manufacturer class. As the CSV resource, we use the uploaded Pimcore asset file. And in the first row of our CSV file, see it here, there are the field names. Then we click the Auto Create button and all the raw data fields get extracted from the CSV. For the manufacturer import, we only need the manufacturer name. So let's delete all those other fields. And then we have to set up to which target fields of our manufacturer class this CSV field should be assigned. So here we have all the fields from the Pimcore class. So ID, object name, path, publish, text, and properties are Pimcore system fields. But there's also name and image, which is our fields from the manufacturer class. And assigning the raw data fields from the CSV to our target class fields is as easy as just selecting them from the list here. When we have done this, we can run the import, go to Data Objects, and there we see our created manufacturers. The name is set and also the object key. Okay, then I'd like to come to the product import. We create another data port named import products. Source data type again is CSV, but target type this time is product. We use the same CSV file and again automatically create the raw data fields which we want to extract from the CSV file. This time we need all of them, so I do not remove any. And now we assign the fields from the CSV file to our product class field. As the object name, I take the product name, and as the SKU, I use the SKU. As the English name, I use the product name. And now we come to the manufacturer. Here I can select manufacturer, but there will be an error. This is because the manufacturer in the CSV file is only a string, and we cannot import a string to a many-to-one relation. And for this reason, we have to tell the data director how it can find a manufacturer object based on that manufacturer name. And for this, we can set up a callback function here. So you see here, there is a field where you can enter code like a callback function. The variables which are available are here on the right side, but you do not need to write that code yourself. For most common use cases, there are already templates which you can just use. In this case, we want to assign the a manufacturer object by the name field. So we just select this, save, and it gets automatically created. This here is named the data query selector. This then gets converted to an SQL query. So we want to find a manufacturer whose name is Lime in this case. Lime is the value from our CSV file. And here on the right, we see that the object /lime gets found, and this is exactly the one which we want to find. For the pass, I'd like to use the same function. Then we have the products directly under their manufacturers. So we have an object hierarchy. Okay, this is done. So let's start the complete import. And when we refresh our data objects, then we see the products are directly created under the manufacturer objects, and when we open them, SKU is filled, English name is filled, and also the manufacturer is assigned in the many-to-one relation. So that's how imports work in general. But of course, there are many other plugins for implementing imports. What makes the data director different to those other plugins? At first, we can use multiple import resources, like files, folders, glob expressions, zip files, and all of them can be either Pimcore assets or files on the file system. Then we can use URLs as import resources. We can use curl requests, which is important when you want to access data from an API. So you want to send an HTTP header or username password with your request, then you can use a curl request. And if even this is not enough, then you can implement a custom PHP script which fetches the data and provides it for the data director. But not only the import resources are flexible, but also the import source formats. Data director supports importing CSV, XML and HTML, JSON, Excel, and data from Pimcore elements. So you can extract data from data object assets and documents. You can extract data from Pimcore reports, and you can extract or import data from the file system. So this is, for example, useful when you have shared a folder with all your asset files and want to automatically import all those asset files from this folder to your Pimcore system. This can be implemented with file system as the import source. But also in the list of features, the data director differs from most plugins. For example, there is context sensitivity. You can skip items if certain criteria are not fulfilled. This means, for example, when you have a folder with all your images inside and you want to import the image files to your Pimcore, then you can skip images whose resolution is not high enough, so does not fulfill your quality criteria, or if the color space of the image is not RGB, for example. Then there's the option to not overwrite a field value if it's already filled. This is useful when you, for instance, import data from your ERP system, for example, the product name, and afterwards you overwrite the product name because in the ERP system it contains some abbreviations and you resolve them in Pimcore. Then, of course, you would not want in the next import run from the ERP system to overwrite your manual changes. So then you can click this option to initially fill the field with the value from the ERP system, but afterwards do not change the value. Then there's the option to only create new objects or only update existing objects. This is important when you edit the data for one object from multiple data sources. For example, you have the import from the ERP system, which creates the business data like SKU, product name, and such things. But then you also have an import from the media server, which automatically assigns the images, the product images, based on the image image file name. For example, when the image is named 123.jpg and the SKU is 123, then you could automatically assign this image to the product. But of course, you would not want the media import to create new products, because those would be rather empty except for the image field. Then you can depend import behavior on values of other import or target objects fields. This means that we can implement logic in these callback functions I've mentioned, where we can analyze other columns of a CSV file or other fields of an XML file and implement if conditions, for loops, or whatever you need. Or we can also check certain fields of the currently imported data object. So we can, when you have a field product name, we could look if the SKU starts with a certain number and then implement some different logic, for example. And then you can create or update multiple objects from one raw data item. As you saw in the CSV file here, we have the categories as a comma-separated list. So it is possible to create category object tracking bikes and another category object city bikes from this one import row in the CSV file. And we correctly handle unpublished versions. This means when there is a new unpublished versions with some changes, then you cannot base a new import on the currently published version which is in the database, because then those unpublished changes would get lost. And for this reason, the data director checks if there is an unpublished latest version, and if there is, then we do the import twice. We do it first for the currently published version and update the fields, and afterwards we do it again for the currently unpublished version. So in both versions, you still have you have the changes from the import, but in the currently unpublished version, you still have the changes which were not published yet. Then some words about performance. All of the listed import file formats get streamed by the data director. This means that, for example, when you have a huge XML file, not the whole document tree gets parsed, but the single items get processed one by one. So this allows for huge import files while keeping memory consumption low. Then there's an option to skip current object if import data did not change since last import. So we remember the hash of the import data which got imported last time for a certain data port. And when the raw data, when the import data did not change since the last import, then we can skip the import completely. And this, of course, provides very high performance then. Then we can fetch related objects only once when multiple raw data items refer to the same element. Back to our demo, we had the manufacturer relation. When you imagine that there are multiple products which relate to the same manufacturer, then the manufacturer gets only fetched once, and when the same manufacturer should get fetched again, then it gets delivered from the cache. Then before saving, we check, we have dirty detection for all fields, and we save the object only if the import changed any data. If nothing changed, then there's no necessity to save the object again. And we save only once if multiple raw data items belong to the same object. This can happen when you import data from folders, for example. Then there could be multiple files, and in those separate files, the same data object could be referred multiple times. And then we import this data one after the other, but we save the data object only once for the complete import run. The side effect of this less saving is that we have a cleaner version history, because not in every import we save the object, but we only save when there really is a change. So you have less versions where actually nothing changed. So let's see some numbers about that. I've here prepared a diagram where we compare the performance of the different import plugins for Pimcore. At first category, I have set up a script which creates objects. So they do not exist yet, but they are newly created. And the number below here is the difference between the data director performance and the best alternative. So here we have 18% better performance than with the best other alternative. For updating, it's quite the same. Here we have the all up to date. This means all objects which you want to import are already up to date. This is what I meant when I said that we can skip the whole import when we recognize that the import data did not change since the last import. Of course, then the performance is much higher, and you might think that this is not often the case, that it's all up to date already. But in fact, it is when you imagine that you have an import which, for example, imports all your manufacturers, then this will not change very often. So when you have a daily import which imports all of them, then you won't have a completely new list of manufacturers compared to yesterday. So only some manufacturers may be added, but in most cases, nothing will be added at all. And then this really comes into play, this performance gain. When assigning relations, like we did with the manufacturer many-to-one relation, we have an even bigger performance increase compared to creating and updating. This is because we cache the querying of the related objects. And if multiple import items refer to the same object, then we have a 43% better performance. This is because the object gets only saved once. Of course, the absolute numbers in this diagram will differ depending on your data model and your hardware resources. Then there's automation. Of course, you can run the data ports manually, but it's better, or in the digitalized world, it's often a common use case that you automatically want to start imports. For example, you can tell your users to upload their CSV file or their Excel file to a certain folder, and when they do, the import gets started automatically. Or another use case is that you can trigger the assignment of a just uploaded asset to a data object via a file name. So for example, you upload a file named 123 JPEG, and then automatically a data port gets triggered, which checks if there is a product with the SKU from the file name, so in this case 123, and if there is, the uploaded asset will get automatically assigned to the product with the SKU 123. And as a third use case, you can implement imports with the same data object as source and target. So this is, for example, to fill some fields with values based on other fields. Actually, that's the same as calculated value fields, but it has some advantages. For example, the calculation can be implemented directly in the Pimcore backend with those callback functions. You do not have to create any separate PHP files. The value in the field, in the text field, for example, can be manually edited afterwards. This is not possible with a calculated value field. And then the value is only calculated when the object gets saved. In contrast to this, for a calculated value field, the value is calculated every time you access the data. So this is also an advantage. Then for every data port, for every import and also export data port, we create a REST API endpoint. With this REST API endpoint, we can implement live interfaces between source and target systems. For example, when you imagine a connection between an ERP system and Pimcore, you could set up an export which creates a CSV file. The CSV file then gets uploaded with FTP, for example, to the Pimcore server, and on the Pimcore server you would set up a cron job which checks the folder where the files get stored or get loaded via FTP. But it's there you always have a delay between the single cron job runs. So when you run the cron job for every 5 minutes, and the ERP system has uploaded the data 4 minutes ago, then you would have to wait until the next cron job run will be done. With the REST API, you can implement in your ERP system to send an HTTP request, and the CSV, for example, which got exported previously as a file, this can now send directly in the HTTP body. And this way you can send this to a Pimcore, to the endpoint, the REST API endpoint, which the data director provides, and get live interfaces this way. So as soon as the data gets saved in the ERP system, you would send the HTTP request and the data will be immediately in Pimcore. So no cron jobs, no delays. So here you see Open API specification of such an endpoint. You have endpoint URL and API key, and in the request body, you send the document you want to import. An important point about imports is traceability. You always want to know where a certain data error came from. Was it caused by an error in the import file? Was it caused by the import configuration, or was it caused by a certain library or after a Pimcore update? Or where did it come from? Perhaps you see in the data object versions when an error occurred. Then it would be interesting to see which import file got used at this time. And for this, you can use the import archive. That's simply a Pimcore asset folder or a file system folder where all the import files for a certain data port get automatically stored. So when you see a certain problem in the data, in a data object version came at a certain point in time, then you can look into this archive folder, which file got imported at this time, and then you can check if there was a problem in the import data. Then we have a searchable import log history for each import run. So here you have the list of import runs, and when you click this finished with errors or finished successfully, you will get the logs for this single run. This is much better than compared to the usual prod log or dev log, what Pimcore provides, because here we have the logs only for this import run. But in the prod log, there are from several places scripts and parallel imports. You would never find the reason why a certain problem occurred. But when you have the logs for a single import run, you exactly see what this one import process did and which values it processed. If there is anything wrong, we saw here that there were some errors, then you get automatically notified via email. The anything is in uppercase letters here because this also, or this even is valid for when using variables which are not set or which are unknown, or if you use an array key which is not defined. In some cases, this might not be a problem, but as imports are really powerful and you can cause a lot of damage with imports, for this reason, you get notified if anything goes wrong or unusual happens. But if anything unusual happens, the data director provides a command to revert the import fields to a certain point in time. This is much better than restoring a database dump, because it could be that you recognize the error 3 days later than it occurred. And perhaps in those 3 days, other changes or fields to other changes to other fields have been done. And when you would restore the database dump from 3 days ago, then all those other manual changes would also get would be lost. And for this reason, we can revert only the fields of a certain data port. So when you have an import which imports the product name, and you truncated this for a certain reason, you can then import only the product name to a certain point in time, and all the other fields will remain the same as they are in the current date. And we have currently in development versioning for import configuration. This is especially important when multiple persons work on import configuration. Then it might be a good idea to check if the import worked yesterday, but it does not work today. Did anything change in the configuration? Then you could see this like it is done with the data object versions, for example. Data director has also a permission system. You can configure which users are allowed to run a certain data port or to configure a certain data port. And for this, the standard Pimcore role-based user permissions are used, so you can assign those permissions to roles or directly to users. Then there's a nice feature called dependent imports or import pipelines. You can chain multiple imports to be executed one after another. Again, to our live demo, it would not be a good idea to run the product import before the manufacturer import, because then the manufacturer relation, the manager one relation, could not be filled because perhaps the manufacturer object would not exist yet. For this reason, you could set up a pipeline to execute first the manufacturer import and directly afterwards import the products. Then you can call another import with data from the first import as import source for the follow-up. This means, for example, when you imagine the WordPress API for blog posts, you can access the blog post data. But when you additionally want to get the media for certain blog posts, then the media is not included in this blog post data. But instead, you get a URL in the blog post data where you can access the media. So you would have two data ports, one for the blog post data and one for the blog post media. But the blog post media data port would get the import URL from the data of the first import. So you could connect them this way. And another thing is that you can check if a relation object already exists, and if not, call a parameterized import to create it. So back to our manufacturer and product import, we could run the product import first, and when we recognize that the manufacturer object does not exist yet, we could call the manufacturer import to only create this one missing manufacturer object. But of course, this only is useful if you use a URL, for example, where you can really request the data for one manufacturer. When you use the CSV file, of course, it would not make sense because there you cannot request only the data for one manufacturer. And then there are some really cool things. The first thing is automatic translation with DeepL or AWS Translate. It's as simple as selecting the source language and configuring an API key, and then automatic translation will work, including caching, including cost optimization and such features. Then there is artificial intelligence. You can automatically assign things to a relational field based on other fields. So in this case, you can assign categories based on the product name and description. When other products have certain terms in the product name and in the description, the algorithm checks which categories those products have. And if the same terms appear in a new product, then this function calculates which category is highly likely. And the third nice feature is optimization. You can minimize or maximize calculated value fields by changing certain data types. For example, when you have a many-to-many relation with some waypoints which you want to visit and have a separate calculated value field where you calculate the distance between the waypoints, then you can minimize this distance to depending on the order of waypoints in your relation. So that's known as the traveling salesman problem, but you can use this optimization algorithm also for other applications like storage cost optimization or for stock portfolio optimization and such things. And every mentioned feature in this presentation is possible without programming, but you can always add your own logic via the callback functions. Okay, then let's come to the exports. For the exports, I've told you in the beginning that they pretty much work the same as imports. So let's try to prove this. I created a dataport export. The source data type this time will be Pimcore objects, and our target class will be export. Our source data class will be product in this case, and we auto-create the export fields. And now we go to attribute mapping, and there are two special fields. These also exist for imports, but for exports they are more important. At first, there is the result callback function. The responsibility of this function is to generate the export document. It is called for each exported object in this case, so for each product this function is called, and its responsibility is to create the export document. And then there's a second function, result document action. With this function, you define what to do with the generated export document. So you could send it as an email, upload it with FTP, or save it as a Pimcore asset, for example. But let's concentrate on the result callback function. We go here to settings, and there are also already some predefined templates. Let's take output raw data as JSON, for example. Then all the code gets automatically generated. And here inside, we see these constructs here. These will generate so-called virtual fields. As soon as we save, we will see that those virtual fields will appear here. And at this stage, it's identically to an import. you can again assign here a raw data field, which we extracted from our Pimcore object source class. But you can also implement your own logic here. So in this case, for example, we could check if the value of the assigned raw data field short description is empty, and if it is, then return 1, 2, 3. We already see it in the preview, and when we run the export, then we see that here is our 2 products, and when we look closer, then we see for the short description 1, 2, 3 gets exported. This is because of our callback function, because we have not imported short description, so it's always empty in this case. But of course, you can implement any logic in those callback functions. But of course, there are also other plugins for exports. So what makes the difference between the data director and other plugins? We often hear that the export format is very complex and this does not work with other export plugins. But with this callback function, which I've shown, the export format is fully flexible, so you can define it as you want. You can export anything. Any export document can be created. For common use cases, export format templates are included already in the bundle. So like we did with the JSON export, there are already templates for CSV, XML, and Excel. And all of the above also including reference assets. So when you export, for example, an image gallery, then you could create a CSV file, and inside the CSV file you would refer to image files, and those image files would get added also to the zip file. So in the end, you would end up with the CSV file and the assets, and this all together compressed to a zip file. Then there are other enterprise export templates for Google Shopping, Facebook Products, and BME Cut. Those are available as add-on bundles. But there are also ready-to-use export templates for API usages like XT-Commerce, HubSpot, or JTL. Currently in development are export templates for Shopify, Shopware, PrestaShop, and BigCommerce. For exports, there is the option to extract the data in the background as soon as an object of the configured source data class for the export dataport gets saved. This means that in the moment where the export is requested, no data has to be fetched from the Pimcore objects, but it is prepared, or it got prepared already when the object got saved. So this is much faster, of course. In the moment when the export gets requested, only the export document itself, so the JSON file or the XML file, has to be generated with the already prepared data. So this is quite fast. Then there is an intelligent check if anything changed since the last export. If nothing changed, then we can directly deliver the export document. So we do not even have to create the export document again. And if nothing changed and the client already has the up-to-date export document in cache, then the client does not even have to download the export document again. So this can be a browser cache or a proxy cache or something similar. Then, like on imports, we also have automatic exports. You can use those to, for example, trigger an export to a target system when an object changes. For instance, you can implement a push API to a webshop or an ERP system. As soon as you save your product, the data gets automatically pushed to your webshop. Or another use case is when an object of a dataport source class gets saved, you can generate an export document like a product datasheet and upload it via FTP. With the data director, it's possible to export anything. You can access any data which is connected to the exported object without implementing any PHP files or similar. Everything is done directly in the Pimcore backend. One special thing about the data director is that you can export all object brick or classification store fields without listing each single field. So you can just say or define that you want to export the object brick container, and then all the object bricks and all the object brick fields get exported as the data. And when you add a new field or delete an object brick field, then the export will automatically be adjusted. It's also possible to access data of other objects than the currently exported one. So when you want to access some other data which is not connected to the currently exported object, then this is also possible. And you can preset filters for objects to be exported. For example, you could set up a condition to only export published objects. then it would never be possible with this dataport to export any unpublished objects. Also for exports, we have a REST API. With this, you can access the exports via URL. In the URL, with URL parameters, you can change the filter condition to be used, the language, and even the logic with URL parameters. This URL can then be used as a data feed on software as a service platforms like Products App or Google Shopping, Fact Finder, DoFinder, or Easy Catalog. Or of course, you can use this API endpoint in your web or infrastructure applications. So it looks the same as for imports, but this time it's HTTP GET. We have a URL and we have some parameters to configure what we want to actually export. Then you can use the data director for internal checks and transformations. Technical speaking, this is imports with the same source and target. So we extract the data from a Pimcore data object and import again into this same object. You can use that for data quality checks, for example. A use case would be that if a product has no price, then it must not be published. Then you would set up a dataport where you extract the product price. And if this is empty, then you would set up in the attribute mapping in the published fields, that it should be unpublished when there is no product price. So then it would never be possible that a product without a price would get published. Another use case would be if the field price is not filled and the object has not changed for over a week, then we could send an email to the product team to care for this product. And you can use the same mechanism to change field types without losing data. So imagine you have a select field currently and you recognize that it would be better to have a many-to-many relation. Then you cannot simply convert the field to a many-to-many relation because the data structure in the database is different for relational fields. In this case, you could set up a data port which extracts the current data from the select field for all objects and afterwards add a new field or change the field type, pretty much the same. And afterwards, you import the data which you extracted from the select field to the new relational field. So this is changing field types without losing data. And then there's a really cool thing named grid exports. You already know probably grid exports because they are implemented in the Pimcore core. When you click on the folder on the data object section, then you get this grid view. And this grid view can be used to filter the objects which are shown, and also you can select the single items. And with this, you can then trigger an export. This is already built in Pimcore. But the data director, you can do the same, but you can then trigger a data director export with the selected and filtered elements. And that's a good idea because the Pimcore's built-in grid exports have some problems. First thing is that there is no reuse of previously generated export data. With the built-in functionality, the export data is newly fetched from the database in the moment when the export is requested. This is quite slow. In contrast with the data director, the export data is already prepared when the objects got saved. Then for grid exports in the Pimcore core, no predefined filters are possible. Even if you save the grid configuration, the filters which you have used are not saved in this grid configuration. With the data director, you can set up such an SQL condition. Then, of course, that's obvious. There is limited configuration of export formats. Currently, only CSV and Excel formats are supported. But with the data director, you can implement any export format. And the last problem is that you can only download the generated export file. There is no possibility to set up an action to be executed after the export document has been generated. With the data director, it is possible. You can create the document and afterwards upload it to a certain server or save it as an asset, for example. And like I've said for imports, it's the same for export. Every mentioned feature here is possible without programming, but you can always add your own logic via callback functions. Yes, on this slide, I've listed some customer voices. I will not read that up for you. You can hopefully read them yourself. Until today, we have 100% customer satisfaction for all the customers who use this bundle. So yes, we are quite proud of this, and we hope to continue this also in future. Yes, that's the Pimcore data director. I've listed here some links where you can get more information. You can download the presentation afterwards. Yes, that's it. Thank you for listening.